In January of 2022, Keir Finlow-Bates released this fascinating article about creating the world's largest airdrop. Now, an airdrop is generally when a crypto project releases tokens or some form of cryptocurrency away to users for free. The purpose of an airdrop might be to reward users for early adoption or to incentivize some people to join this project. Basically, Keir Finlow-Bates created an ERC20 smart contract, and the smart contract is creating a token called DETS token, DETS, and it gives 100 tokens to every single wallet address. So first I'll show you how you can claim these tokens yourself. So if we scroll down to the article, we have a link to the address on Etherscan. So this is deployed on the mainnet, and we can copy the smart contract address here. Next, if we go into MetaMask, then we can use this contract address to import the token and claim our free airdrop. So currently you can see that in my MetaMask, I currently have no tokens, and now I can import these DETS tokens. So go to custom token and paste in that smart contract address, and it fills in the DETS symbol. And then if I click add the custom token, it says I have 100 of them. And now I can import them, and now I can see the DETS tokens in my account. Because this is an ERC20 token, you can do all the things you can with the normal ERC20 token. For example, send them to another address. In this article, he doesn't really describe the code that he used to create this ERC20 contract, and I was really fascinated by how airdrops work and how you could airdrop something to every single address. So I looked at the code in the smart contract and I thought it was really interesting and decided to make a video about it. So let's first go over the goal of our project and then decide how we might write this in code. We have a pretty ambitious goal. We want to airdrop tokens to every single address. This includes every existing address as well as every future address. How is it even possible to airdrop tokens to an address that doesn't even exist? One naive brute force approach might be to generate a list of every single possible address, and then you can send tokens into every single address. However, that's extremely inefficient. Why is this impossible? This is because every single Ethereum address is made up of 40 hexadecimal characters. Technically it's 42 characters, but the first two characters are always going to be 0x, so we can ignore those. Each character can have 16 different values because it's hexadecimal, and therefore the number of unique addresses is 16 to the power of 40. That is an extremely large number, and if you had to send tokens into every one of those addresses, the gas fees would be enormous. Not to mention it would also take a very long time. Therefore, to unravel the mystery of how he did this, we can just look directly at his code to see the answer. So if we scroll down, we have the contract on Etherscan. And when we open that in Etherscan, we can go to the contract and then read the code. So you can see that when this ERC20 smart contract is deployed on the blockchain, we're actually not doing anything in the constructor because the constructor is empty. Rather, the only thing that's happening is that as soon as this contract is created, if you try to look up the balance of any account, that balance is going to be 0, and therefore you're going to return 100 tokens. I think this is extremely clever because this means that you're allowing the balance of everyone's account to actually be 0, but when they try to query the balance, they're actually getting 100 tokens. But how are we going to allow users to transfer their tokens between each other? Because it's an ERC20 contract, people are allowed to transfer their tokens, and that means if my token balance goes from 100 to 99, the contract does have to keep track of that. So we can go down to the other files to see what's happening during a transfer. So let's go to the second file, ERC20.sol. So if you go down to line 225, you can see how this contract is implementing the transfer method. It's a normal ERC20 transfer method, which means that we have a sender, a recipient, and amount, and this method will allow the sender to transfer some amount of tokens to this recipient. Here we have some normal checks, like checking that the sender is not the 0 address, and also checking that the recipient is not the 0 address. And now the clever part here is on line 235. So basically we're saying that if the balance of the sender is equal to 0, then we're going to initialize their account with all these tokens, and then we're going to emit a transfer event. In addition, if the balance of the recipient is also 0, then we're also going to initialize their balance with a bunch of tokens and then also emit another transfer event. Afterwards, then we're going to perform the transfer, which is that we're going to send some tokens to the recipient. So here we're going to take the balance of the sender and we're going to subtract the amount that's being transferred. And then we're going to take the balance of the recipient and we're also going to increase that balance by the amount that's being transferred. And then we'll also emit another transfer event. In addition, Keir Finlow-Bates made a requirement that you can only transfer a maximum of 1 DETS token per transaction. So here we're checking that the amount is less than 1 followed by 18 zeros. So let's go back to line 235. What exactly is this code doing? So basically this is saying that if the balance of the account is equal to 0, then we're going to initialize that balance with the tokens. This is very clever because it defers the rights to the blockchain to when the transfers actually occur. This concept is very similar to lazy initialization in computer programming, which is a technique in which you're delaying the creation of an object, the calculation of a value, or some other expensive process until the time when it's needed. You can see the parallels here with this ERC20 contract. That's because for this contract, you have an infinite, well, not infinite, but you have an extremely high number of accounts. And the majority use case for this contract is that really people are not going to interact with their accounts because there are so many of them. Most people are not even aware that this contract exists, and it costs real Ethereum to do transfers. And really, why would you want to waste your own Ethereum on transferring these DETS tokens when they really don't matter? As I discussed earlier, when you're deploying this ERC20 contract, you don't want to initialize all those accounts with a balance because that would be extremely costly. However, if you can delay the initialization of the account balances to an actual transfer, then the amount of gas spent is actually only the amount of gas spent for those two accounts. So let's say the contract was deployed in January of 2022, and Alice wants to transfer one of her DETS tokens to Bob. So Alice is going to call into this transfer method, and now this method will see that Alice's balance is actually 0, and Bob's balance is actually 0. So then it's going to initialize Alice's account by transferring this number of tokens into her balance. And then the same thing will happen for Bob. So now, literally, according to the contract, the balances mapping has 100 tokens for Alice and 100 tokens for Bob. And then we can continue with the actual transfer to transfer tokens from Alice to Bob. So after that transfer, then Alice and Bob would have 99 tokens and 101 tokens respectively, and everyone else would have 0 tokens. If Alice were to query her balance is not 0. So then the logic would enter into this else statement, so it would return Alice's balance. And the same thing would happen for Bob, because Bob's balance is now actually 101 tokens. So again, if Bob were to query the balance in his account with balance of, the logic would enter this else statement and it would actually return Bob's balance. Whereas for everyone else's account, those accounts have never been modified before, so their balances would still be 0 and they would return 100 tokens. Now there is one trickier part to this contract that Keir implemented, which is why are we returning balance minus 1? The key here is in line 235, where you can see that if the balance of a sender is ever set to 0, then the smart contract is automatically going to add 100 more tokens into their account. So this means that you start out with 100 tokens, and if you somehow manage to transfer all your DETS tokens to someone else, once your balance goes back down to 0, the contract is automatically going to give you 100 more DETS. So you're going to be like forever in debt, which is one of the little jokes that Keir Finlow-Bates had when he created this contract. So the idea of using 1 here instead of a round number is to prevent this cycle from happening. Let's look at this visually. The smart contract is initializing the account balance to 100 tokens plus this one small token here. And then let's say you transfer 1 token to Charlie, 1 transfer to Dan, and then 1 token to Eva, and so on and so forth. So after 100 of these transfers, you're going to be down to 1 single unit. At this point, if you query your balance, the balance is not equal to 0, it's actually equal to 1. So we're not going to enter the if block here. Instead, we're going to enter the else statement. And here you're going to return balance minus 1. So in this case, your balance would be returned as 0, when in fact your balance is literally 1. Now at this point your balance is 0, and you've paid off all your debt. Now let's go back to our transfer method. So now with your balance being literally 1, if you try to transfer that 1 token out, you would not enter this if block here because the balance is 1 and not 0. So this is to prevent your balance from being reset to 100 tokens when it looks like your balance is 0. So there's a way that actually if you do transfer that single 1 out, then your balance will really be reset to 0. And that means the next time you do a transfer, you will indeed get 100 more tokens. So this is to prevent the situation where someone might transfer all of their debt out and they'll query the contract and see that their balance is 0. And in that case, we don't want the smart contract to automatically send 100 more tokens into their contract. So there's a trick where if you do manage to pay off all your debt and you do want to get back 100 more debt tokens, then you would have to do another transfer for a unit of 1. You start off with 100 debts tokens, and technically you can pay it off. But even though the smart contract says your balance is 0, you actually have a debt of 1 unit. If you transfer out that 1 unit, then your debt is automatically reset to 100 tokens. This is good if you want to accumulate debt and have infinite debt, but some people may not want that. Keir also touches on this in his last paragraph, which is the idea was to have a token that no one would really want and that only the rich could transfer away easily, a bit like debt and hence a limit. For more details, I highly recommend reading this article. Keir is a wonderful teacher. He has a YouTube channel and he has a ton of amazing articles which can teach you a lot about Solidity and the blockchain worlds. His DETS token contract has a lot of funny philosophical undertones, and we can learn a lot about it from ERC20 to lazy initialization. If you have any questions, or if my explanation was not clear, please do leave a comment below and I'll be happy to respond. Please give a like and subscribe, and I'll see you in the next video.